Today we will talk about an incredible astronomical event that will occur on March 3, 2026. On this night, our moon will turn into a fiery red ball, and millions of people around the world will witness one of the most dramatic celestial performances, a total lunar eclipse. What is a lunar eclipse? This is a cosmic ballet of three celestial bodies, the Sun, the Earth, and the Moon. When these objects line up in a perfect line, the Earth is exactly between the Sun and the Moon, casting its shadow into the depths of space. And when the Moon enters this shadow, an eclipse begins. But it is important to understand that the Earth's shadow is not homogeneous. It consists of two parts. The outer, lighter part is called penumbra or penumbra. Here, sunlight is only partially blocked by the Earth. The inner, dark part is a complete shadow or umber. It is when the Moon enters the umber that the most interesting thing happens. Many expect the Moon to simply disappear, plunging into darkness. But nature has something more impressive in store for us. The Moon does not disappear, it becomes red. Dark red, copper red, sometimes almost orange or even brown. Where does this mysterious color come from? The answer lies in our atmosphere. The Earth is surrounded by a layer of air about 100 kilometers thick. When sunlight passes through this atmosphere tangentially, that is, along the surface of the planet, a phenomenon called Rayleigh scattering occurs. Air molecules scatter short-wavelength light, blue, violet, green, in all directions. And long-wavelength red and orange light passes through the atmosphere almost without loss. This is the same effect that paints our sunsets and sunrises in red and orange tones. During a lunar eclipse, the Earth's atmosphere works like a giant lens, refracting and directing red light to the Moon's surface. It turns out that the Moon is illuminated simultaneously by all sunsets and sunrises on Earth. Imagine this: if you were standing on the Moon at the moment of the eclipse and looking at the Earth, you would see the black disk of our planet surrounded by a thin ring of fire. This is the atmosphere shining with the red light of all earthly twilight. The color of an eclipse is never the same. It depends on the state of the Earth's atmosphere. If there is a lot of volcanic ash in the atmosphere, for example, if there was a major eruption shortly before an eclipse, the Moon will be dark, almost brown. If the air is clean and transparent, the Moon will shine bright red or copper orange. If there are a lot of clouds and water vapor in the atmosphere, lighter, almost pink shades can be seen. Astronomers use a special scale to assess the brightness of an eclipse, the Dunjon scale. It goes from 0 to 4. 0 is a very dark eclipse when the Moon is almost invisible, dark gray or brown. 1 point is a dark gray or brown eclipse with a dark center. 2 points, red-brown with a lighter edge. 3 points, a brick red eclipse. A magnitude 4 is a very bright copper red or orange eclipse with a bluish edge of shadow. The eclipse on March 3, 2026 will be visible over a vast area of our planet. Residents of Europe, Africa, Asia, and Australia will be able to observe this phenomenon in whole or in part. Unfortunately, for the inhabitants of both Americas, this eclipse will be inaccessible. At the time of the event, the Moon will be under the horizon there. The total phase of the eclipse will last about 65 minutes. This is more than an hour of continuous spectacle. The Moon will be in the constellation Virgo, one of the largest constellations in the zodiac. The brightness of our satellite will drop from the usual -12.7 magnitude to about +3 or +4. This means that the Moon will become about 40,000 times dimmer than usual. When the Moon plunges into the Earth's shadow, dramatic changes occur on its surface. The temperature drops by about 200 degrees Celsius in just an hour and a half. This is an incredibly sharp drop. Moonstones, heated by the sun to plus 120 degrees, suddenly cool down to minus 80 and below. This causes thermal stresses in the rocks. The stones shrink and crack. Some scientists believe that moonquakes may be related to these temperature shocks during eclipses. The history of observations of lunar eclipses goes back to ancient times. More than 2,500 years ago, Babylonian astronomers kept detailed records of eclipses and learned how to predict them. Chinese scientists recorded eclipses on bone and tortoiseshell shells back in the era of the Shang dynasty, 3,000 years ago. But not all cultures were calm about eclipses. For many peoples, the red moon was a harbinger of trouble. Mesopotamian kings hid during eclipses, appointing a temporary ruler to their throne. If the gods were angry, let their wrath fall in replacement. The Incas believed that during an eclipse, the moon was attacked by a jaguar trying to eat it. People ran out into the streets, shouting, beating drums, throwing stones, and shooting arrows into the sky, trying to scare off the celestial predator. The Vikings told a legend about two wolves, Skoll and Hati, who eternally chased the sun and the moon through the sky. When the wolf catches up with its prey, an eclipse occurs. People should help the heavenly bodies by making as much noise as possible. In South America, some tribes believed that the moon was sick and needed healing. They sang songs and prayed for her recovery. But there were also those who used eclipses for science. The ancient Greek philosopher Aristotle in the 4th century BC carefully observed lunar eclipses. He noticed an important detail: the Earth's shadow on the moon is always circular, regardless of where the moon is in the sky and at what time the eclipse occurs. Aristotle made a logical conclusion: if a shadow is always round, then the object casting this shadow must be a sphere. This was one of the first scientific proofs that the Earth is a sphere, not a flat disk. Later, in the 2nd century BC, the Greek astronomer Hipparchus used observations of lunar eclipses to calculate the distance to the moon. His estimates were remarkably accurate. He obtained a value of about 60 Earth radii, which is very close to modern data. The distance to the moon ranges from 56 to 63 Earth radii due to the ellipticity of the orbit. In the Middle Ages, astronomers in the Islamic world made significant progress in predicting eclipses. They discovered the Saros cycle, a period of 18 years, 11 days and 8 hours through which eclipses repeat in a very similar sequence. If there is an eclipse today, then a very similar eclipse will occur in one Saros, but shifted by about 120 degrees of longitude on Earth. The Saros cycle contains 70 or 71 eclipses and lasts about 1,300 years. Christopher Columbus once saved his expedition thanks to the knowledge of an upcoming lunar eclipse. In 1504, he found himself in Jamaica, and the locals refused to provide him with food. Columbus knew that a lunar eclipse was about to occur. He informed the chieftains that his god was angry and would hide the moon as a sign of displeasure. When the eclipse actually began, the frightened natives begged Columbus for forgiveness and agreed to supply his people with everything they needed. Today, lunar eclipses serve as a tool for studying the Earth's atmosphere. As light passes through our atmosphere and illuminates the moon, it carries information about the composition of the air. Astronomers analyze the spectrum of this light, that is, they decompose it into individual colors and study which wavelengths are present and which are absorbed. These data can be used to determine the concentration of ozone in the upper atmosphere, the presence of volcanic ash, aerosol air pollution, and even climate change. Moreover, the study of lunar eclipses helps astronomers prepare for the search for life on exoplanets. When a planet passes in front of its star, the star's light passes through the planet's atmosphere. By analyzing this light, you can find out what the atmosphere of the distant world is made of. Lunar eclipses are a model situation where we can work out the methods of such analysis on the example of the Earth. How to observe the eclipse on March 3rd. Great news! Unlike solar eclipses, lunar eclipses are absolutely safe for the eyes. You can look directly at the moon with the naked eye without any protection. No special filters or glasses are required. The moon simply reflects sunlight, and even in its normal state, it is safe to observe. For observations, it is best to choose a place away from city lights. The light pollution of cities won't prevent you from seeing the moon itself, but the darker the sky, the more detail you'll notice and the more stars you'll see next to the eclipsed moon. Find a place with an open horizon where there are no tall buildings or trees blocking the view. Binoculars or a small telescope will greatly enhance the experience. Through binoculars, you can see that different parts of the moon are colored in slightly different shades of red. Dark lunar seas, ancient solidified lava flows, look darker than light elevations. Through a telescope, you can try to see large craters even during the total phase of the eclipse. Pay attention to the edges of the Earth's shadow. Sometimes you can see a bluish or turquoise border around the shadow. This is the result of light scattering in the ozone layer of the Earth's atmosphere. Ozone absorbs red light but lets blue light through, creating this unusual color border. Photographing the eclipse is interesting and not too difficult. You will need a camera with manual settings, a tripod, and preferably a telephoto or zoom lens with a focal length of at least 200 to 300 millimeters. The longer the focal length, the larger the moon will be in the picture. At the beginning of the eclipse, when the moon is still bright, use a low ISO, 100 to 200, a fast shutter speed, 1/125, 1/250 of a second, and a medium aperture, f/8, f/11. As the moon gets darker, increase the ISO and lengthen the shutter speed. During the full phase, you may need a shutter speed of a few seconds and ISO 1600 to 3200. Try taking a series of photos throughout the eclipse, and then combine them into one composite image showing the moon's path through the Earth's shadow. Such collages look very impressive. Include the foreground in the frame, silhouettes of trees, buildings, mountains. This will add depth and scale to your shots. Interestingly, during an eclipse, the sky becomes significantly darker, and stars appear that are usually lost in the moonlight. The moon in its usual brightness illuminates a fairly large area of the sky around it. But when it darkens during an eclipse, this area is filled with stars. The constellation of Virgo, where the moon will be located, will become much clearer and more beautiful. In the constellation Virgo, there is a bright star Spica, a blue-white giant located 250 light-years away. This star is 12,000 times brighter than our Sun and about 11 times more massive. During an eclipse, Spica will shine especially brightly in the darkened sky. Next to the constellation Virgo is the constellation of Leo with the bright star Regulus. You can also see planets nearby. Check the astronomical calendar to see which planets will be visible in March 2026. The eclipse on March 3rd is especially symbolic because it coincides with an important period in space exploration. In 2026, the so-called launch window to Mars opens, the period when Earth and Mars are in the optimal position for interplanetary flight. These windows open about once every 26 months and last only a few weeks. SpaceX plans to use this window to send the first unmanned Starship ships to the Red Planet. These missions will be test missions before future manned flights. The ships will deliver to Mars the equipment, fuel plants and supplies needed for the first colonists. Imagine, while we are observing an ancient celestial phenomenon, the dance of the Earth, the Moon and the Sun, humanity is simultaneously preparing to take a giant step towards becoming an interplanetary civilization. This is an amazing moment in history. For thousands of years, our ancestors looked at the red moon with superstitious fear or scientific curiosity, but always remained attached to the Earth. Now we are witnessing the same phenomenon, but as a species preparing to leave its cradle and spread throughout the solar system. If you missed the eclipse on March 3, 2026, the next opportunity won't come soon. Total lunar eclipses occur about once every year and a half, but not all of them are visible from the same area. So if the weather allows and the sky is clear, don't miss this chance. Prepare in advance. Check the weather forecast a few days before the event. Find a suitable place to observe. Take warm clothes, the nights in early March are still cool in many regions. A thermos with hot tea or coffee, a blanket, a comfortable chair or a sun lounger, all this will make your observation comfortable. Invite friends or family, it is better to experience such events together. If you have children, this is a great opportunity to awaken their interest in astronomy. Tell them the history of eclipses, explain the mechanics of what is happening. Show them that science can explain even such mysterious phenomena. And most importantly, let them feel connected to the cosmos, the feeling that we live on a planet that dances in space along with other worlds. Lunar eclipses remind us of our place in the universe. We live on a rock ball orbiting a medium-sized star, on the outskirts of an ordinary galaxy, among billions of other galaxies. But at the same time, we are the only known beings who can understand the mechanics of celestial movements, predict eclipses thousands of years in advance, and marvel at the beauty of the cosmos. Each eclipse is a connection through time. The same laws of physics that govern the movement of celestial bodies today worked billions of years ago and will work for billions of years in the future. The moon we'll see red on March 3 is the same moon that dinosaurs looked at 100 million years ago. The same moon that inspired the first people when they were just learning to think and speak. And the same moon that future generations of humanity will one day set foot on, creating a new home there. The eclipse of March 3, 2026 is not just an astronomical event. This is the moment when the sky reminds us of the beauty and orderliness of the universe. This is a chance to break away from everyday worries, raise your eyes to the stars and feel awe for the infinity of space. This is an opportunity to become part of an ancient tradition, the tradition of people observing the sky and trying to understand their place in the universe. Don't miss this night. Go outside, look at the red moon, feel the cool night air, hear the silence of the sleeping world. And know that at this moment, millions of other people across the planet are doing the same thing, all of us together, children of the same planet, witnessing one of the greatest performances that nature has to offer. I wish you clear skies, clear horizons and unforgettable impressions from the blood moon on March 3, 2026. See you under the stars.